Hey, thanks for coming. My name's Ben. I'm an architect developer at Theatre UK, which is a startup that helps other startups launch digital products. And today I want to talk about serverless scheduling, so using Python and step functions in AWS to schedule events like emailing, billing, whatever it is in your application without the need for any servers that you can see. So as I mentioned, I work for Theatre. We're a startup that help other startups launch digital products. This is an example of the project I was working on earlier this year. So Made.com are a large e-commerce startup in London and various other European countries, and we help them rebuild their website, their mobile app, and an interactive in-showroom experience. This is one of our more front-end leading projects, but we're all full-stack engineers, and today I want to talk to you about some of the newer stuff I've been doing in serverless. So as I mentioned, we're full-stack. Previously, that's been a lot of Django on the back end, but more and more I'm trying to move more projects to serverless because of the advantages I'll go on to in a second. Before I jump into the talk, there's a couple of things I'm doing outside of my day job at the moment. So I run a blog on serverless transformation. If anyone's interested in serverless or anything from this talk, feel free to follow it, and I'll put a link at the end. And I also run a newsletter each week with the top 5 articles of the week, and that QR code will be at the end as well. So yeah, what is serverless? Has anyone here deployed a Lambda function before? If you raise your hand. Cool, so a good mix. Or in any other cloud provider, there are similar concepts. I'm going to quickly go over what serverless is because it means different things to different people, and then we'll jump into some Python. So what is this serverless thing? Well, serverless is an architectural movement from my point of view. It's also the name of a framework, which is super confusing. So serverless is an infrastructure as code framework that's really good to use, but it makes talking about the topic a little bit confusing. Why I say it's an architectural movement is because it changes the way developers work. We send pure source code to our cloud provider, and it's run in abstracted containers, which are completely isolated from us. It can scale up to many instances. We're not concerned with the operating system, and we can just focus on the business value to our application. Why do people do serverless? Well, there's a cost reduction. You might have seen the Hacker News article recently, which puts that into question a bit. But with the right use case and using the right services, so not necessarily API gateway for all services, it can work really well and reduce costs, and I've seen that in several clients. There's a move to, some people call it no-ops. It's definitely not that from my point of view. It's DevOps, but it's doing DevOps even better. It's developers having autonomy to deploy new environments extremely quickly, but ops helping them, coaching them, and providing automation. It also allows developers to focus on business value. On the previous slide, I also mentioned that it's not just this sending of application code in functions as a service, but it's using third-party cloud-native services where necessary. So instead of building your own user authentication, using something like Okta or Cognito in AWS to manage users, without having to have servers and code running that, really just trying to use everything as a service that you can. It's more scalable, so it's scalable from day one. You don't have to think about scaling so much as long as your code is stateless, which serverless sort of really enforces. And as we make better usage of server utilization in data centers, we can actually reduce the amount of data centers we need, which could reduce the carbon footprint of the internet, which at the minute is equivalent to the aviation industry, and it's only growing with the rise of streaming. Anyway, serverless is not just functions as a service. AWS Lambda is what people often talk about, but it's all of the non-provisioned services of your cloud provider of choice. Here we have AWS with S3 for storage, DynamoDB as a serverless database, API gateway for routing, Cognito for user authentication, SQS for queuing, step functions, which is going to be the topic of this talk, and many other AWS services where you're not managing the servers yourself, or not even aware of the servers. This obviously gives a great deal of power and flexibility, and you can build really interesting event-driven architectures. But today we're going to focus in on Lambda and step functions to do our serverless scheduling. So AWS Lambda is the function as a service from AWS. And it lets you send up application code that's run in isolated containers. They can scale out to thousands of Lambda functions. You can set rules around this, and it can be triggered by many different services. In terms of runtime, there are many natively supported ones, Node.js, .NET, Ruby, Go, and Python. And you can either run your own custom runtimes using Lambda layers. So I have a client at the minute doing serverless PHP. I wouldn't recommend it, but you can. And there's a great deal of flexibility. As you can imagine, we're going to do serverless Python. So natively supported, there's Python 3.7, 3.6, and 2.7. The way AWS works with versions is as they become deprecated, they move off the platform. But if you do have some legacy code that you're running, you can do custom runtime environments to use particular versions of Python as needed. We're going to keep super simple, though, in this talk. So what is the function, that pure function we're sending to a cloud provider in the AWS Lambda model? Well, it's called a handler function, and it takes two things. An event, which is a dict depending on the service. So API gateway is a dict of the data passed in, so sort of converting the JSON. From other services like SQS, the format changes, and it's also context. So that's the context of the request. So maybe some metadata about the request ID and any X-ray tracing you might have, further logging data, and other things you can configure. And all we need to do is return some value. So in a super basic example, we're taking in an event. That event has the, we seem to be losing connection here. All right, let's try and not move this too much. So we have a handler function that takes an event in a context, and then it can return a response. So handler function, it's triggered by AWS whenever whatever triggering you is coming in. With API gateway, that's often a get, post, put HTTP request. The serverless framework is super useful for managing infrastructure as code. So the serverless framework lets you write pure infrastructure as code in YAML. It's quite level and abstract to different cloud providers, which can help you work differently. Should I try that? Okay, that seems to be working better. Sorry about that. So the serverless framework lets us do infrastructure as code, abstracted to different cloud providers, and has several helpers that make it really simple to get up and running. So how do we install the serverless framework? Well, we can install it with NPM. Sorry to mention NPM at a Python conference. I won't be too popular, but we won't see any JavaScript, I promise. So we install it globally, and then we can run serverless create with the template AWS Python 3, which is using 3.7, and the path, which is whatever we want to call our service. This will then generate for us a serverless.yaml file, which is our infrastructure as code, and a handler, which is a handler.py, which is the function that's going to handle the events. So here we have a simple hello. It takes an event in a context, it builds a body, and then it returns with a status code, a JSON dump of that body. And let's say this is triggered by API gateway from a front-end single-page application. These will click. An API request will come through to API gateway in AWS. That will trigger a Lambda function, which will then send back the response, which will come back through to the user. The serverless.yaml is quite simple here. We just have the name of the service, the provider, which is AWS, the runtime, which is Python 3.7, and then the handler function, which is hello here, and we're doing handler.hello. We can invoke this locally on the command line with SLS invoke local with -f hello, and the response comes back with that status code and body. If we want to deploy it to AWS or other cloud providers, we do SLS deploy. We then do SLS invoke -f hello. So the difference here is we don't have that -local or that local option, and we get the response back. So that's running in whatever region in AWS we choose to deploy to. And here we're triggering with API gateway. There are many services in AWS or other cloud providers that can trigger function as a service. You could trigger with Cognito, which is user authentication, Lex, DynamoDB, EventBridge, and step functions, which is one we're going to talk about, and probably other ones I've missed here. That's serverless in a really quick overview. Let's jump back to the use case. So the problem I was trying to solve in a project was scheduling of emails. It was a platform, I won't go into the business context, but basically they needed to get a load of users to be sent an email, and other users who are admins could schedule those emails to go out. So a pretty basic use case, but really this could schedule any event that's dynamic. This isn't a cron that's happening at the same time every month. This is something that's changing for different users. So in Python, we'd often think Celery, right? So we can manage workflows, it's distributed, and yeah, it's written in Python. It's nice, it can work on top of RabbitMQ quite well. If you want to schedule things, Celery Beat integrates well with Celery. It's a scheduler that kicks off a task at regular intervals, and it basically checks a database for tasks that are scheduled. So you're polling a database. It could look something like this, a couple of app servers, RabbitMQ as your message broker, Celery Beats, and then Celery. Don't have multiple Celery Beats, because otherwise strange things happen. And then an SQL database that the task is being written to, and then it's polling. But as you can probably tell from the start of this talk, I don't want that many servers. I don't want to see any servers. I just want to write application code. And this is where step functions come in, and we found a really nice flow in our project for how to manage this. So step functions let you coordinate multiple AWS services in a workflow that allow you to, in a serverless way, have a workflow through different services. It looks something like this, so it's a finite state machine basically, a bit like Celery. You can have a number of different steps, a start and an end, and it will work through. You can have different conditions. There's a number of different ones supported, and the list is growing currently. In Cloudformation, which is the native infrastructure as code for AWS, it's a bit verbose. That's just one step that says hello, and that's too much infrastructure as code for me. So serverless step functions is a nice plugin to the serverless framework. The serverless framework has quite a nice plugin model that's quite easy for people to contribute to. And here, once we've installed the serverless step functions plugin, we can find a state machine with a name. We can say what the states are, and we can say if that's the end state, and that's all we need to do. Jumping back to our use case of scheduling emails, We wanted two use cases. We wanted first in, first out. User clicks a button, people get the emails. And we also wanted a date queue. We started calling this first in, date out. It doesn't make a lot of sense, but the name stuck. So Fido was born, which obviously has a logo. Once you give things names, they don't go away. So this is going to stay for many years, I think, at that company. And it's also, turns out on Wikipedia, is a demonstration of unwavering loyalty, which always sounds good from a scheduling service. So we stuck with it. So what does Fido look like? Well, it's a first in, date out queue, which isn't a thing. But we have API gateway, which is triggering a Lambda function called email. So the user presses whatever button, and we send an event through to trigger the email. This will then trigger an instance of a step function, which is a start state, a wait state, which I'm going to go into in a minute, but that waits to a given date time or to a particular number of milliseconds. And then we have a push onto SQS, which is a queuing service of AWS. That allows us to have a nice dead letter queue and retry logic. And then we can have a Lambda function to send an email, a Lambda function to send a push notification, a Lambda function to generate a report. It's quite agnostic to what you're doing at the other end. Let's look at the state machine. So we have start, wait, push, and end. Now, wait is an interesting state because the whole idea of serverless is you're billed based on your runtime. If I'm scheduling an email for 3 months' time, I don't want to be billed for 3 months. It makes no sense. Luckily, step functions are billed in quite an interesting way. You're charged based over the number of step transitions in your application, not over the runtime. So here we're charged for each of those transition steps, not for how long we're waiting for. You're limited to wait for a year. You can't go longer than a year, which for some use cases won't work, but for our use case was absolutely fine. So we call a Lambda function to schedule email. That triggers start. It will then wait to a given day, like today. It will then push, which is this step here is calling, can you see my mouse? Yeah, this step here is calling the trigger to a Lambda function, and that Lambda function is pushing onto SQS, which will then get picked up by a send email Lambda function. The finite state machine, written in the serverless framework, looks like this. We have a name of the state machine, which is email FSM. We have states. We're going to start at the wait for due date states. Wait for due date is of type wait, as you might imagine. This is the parameter that stores the due date in the event that comes through. And the next state is push email. Push email is of type task, which means it's going to go off and call the Lambda function. And we give the ARN, which is the identifier of that function. SQS, which is a queuing system, also needs to be configured. You could do that in Cloudformation, but I quite like keeping everything in one infrastructure file. So here at the bottom, we can define resources. So we have an email queue, which is of type SQS queue, and we've given it a name. Now, there are lots of other parameters you can give about dead letter queue handling, concurrency, etc. But in the simplest example, you only need these lines of code to get running. This function is not named correctly. This should be send email, but this is what's consuming the other side of that SQS queue. If I jump back to here, this is the Lambda function here that's going to go call our third party to send an email. Here, we're saying event is SQS. If we're using API gateway, we'd say event is HTTP. But here it's SQS, and we give the ARN of that SQS queue. Then automatically, when anything gets pushed on that queue, it will get picked up by the Lambda function. The event we're passing through that step function looks like this. So we have a due date, which is when we want to send out. We have a from, which is the email it's from. A to, which is pycon@theodore.co.uk. And a subject, which is serverless. Now, we actually implemented this a little bit differently. We gave the UUID of a template and then the UUID of a tag, which is applied to different users, because we didn't want this event to get really big. In this simple use case, though, we can store all the data we need inside the event. So the schedule email Lambda function, which is the first one in that flow that gets called on API gateway, what is it doing? So it's using the Boto3 client, which is the SDK in Python for AWS. It's instantiating that, and it's using the step functions part of it. It's then calling start execution. So it gives the ARN of the state machine, which it gets from the environment variable. You can set environment variables for your Lambda functions in your serverless config, so you can pass the ARN through there. We're giving the event.schedule, so that's the name, and the input is the body of the event we've got through. So the event to a Lambda function contains some metadata, and then body, which is then the JSON that was passed through. We're going to pass that through here to be the input of the next step. So at each step of that finite state machine, we're passing the event down. We're then going to return a 200, and we're actually returning the event body. We don't really need to. But what we're saying is, cool, got that. We put it into the finite state machine. We're not waiting around. Lambda functions can wait for 15 minutes. We can't wait 2 months for this to run, and it'd be very expensive. The next step is push email. So we're scheduled email. We're waiting in that step function, and then we'll come on to push email. This needs to push onto SQS, the queuing system. Again, we instantiate Boto3 with SQS. The SQS event we call client.sendMessage. We give the URL of the event queue, of the SQS queue, which again we're passing through from an environment variable in the serverless YAML, and we're passing that body again. So the body's gone all the way through that finite state machine. We've pushed that body into the SQS queue, and that's finally going to be consumed at the end. And the response is 200 event pushed, so we're all good. The final Lambda function involved in this is send email. So here we're constructing mail. So mail is a class that comes from SendGrid, which has actually been bought by Twilio, I think now, but it's an email sending provider. You could use SES in AWS, and there are other providers available. We're then going to construct a client using the API key. Here it's from an environment variable. That's actually not good practice, not what we did. You should use the SSM, believe it's called in AWS, the Secure Secrets Manager, which stores them encrypted and is a little bit more secure. So the Lambda function would have to have the right IAM policy, so the right permissions in AWS to be able to access this key. We're then going to return a response. So we're going to get the response from SendGrid. We're going to print out some data about that, and then we're going to return 200. The email was sent. Everything's good. I'm just going to jump back to the finite state machine for a second. So we started here with schedule email. That's triggered through the Boto3 SDK in Python, an invocation of a step function, which we defined in our serverless YAML. We're then going to use the wait state to wait till a given date time. We're not built on that. That's all abstracted from us. We're not polling. I imagine AWS are doing some polling somewhere, but we don't need to care about that. We're just not running any code between when we've pushed the event and when it actually happens. We're then pushing the event onto a queue, so that push email is the next step after wait. That event body has been passed through the whole way down. We're going into our SQS queue, and then finally send email is listening on that queue. And that was all that was needed to get our scheduling working, and it's worked in production for months, and it's all great. There are obviously some constraints around you can only wait for a year, you can only have 1 million step functions being invoked at the same time, which for some people would go past some limits. They'd probably go past that limit. But step functions are a nice way to create workflows. AWS provides good serverless services for Python, and Python works really well with serverless. And the serverless framework plugins allow you to manage event scheduling quite nicely. You can use step functions, you can use SQS. The syntax is quite concise. That wouldn't be cross-provider. It works very well with AWS. I've not tried it with Azure or GCP, but they're catching up on some of the serverless services, so I think we're going to see that kicking off soon. Before I finish and get some questions, as I mentioned, Serverless Transformation is a blog, and I'm going to write an article and put the slides on from this talk. I'll also tweet out the slides if anyone's interested. I run a newsletter, so every week we send out the top 5 serverless news articles. And this isn't working, but we also run a serverless podcast, which is on Spotify. If you search Serverless Transformation, you can listen to interviews with people doing serverless in production, people doing serverless Python, people doing serverless PHP, if you want to listen to that, and different use cases. And the final thing is we open sourced a tool last week, which is SLS DevTools. So this is a tool to give visibility over your stack. It only works on AWS at the minute with Lambda, but it gives you visibility over where you're deployed, what you've deployed, and logs. This is to give you in-terminal feedback with simple visibility and targeted metrics. As a developer, I don't want to log on to a web portal to debug my backend code. I want to stay in my IDE and my terminal and not really leave anything else. So we get this interface in our terminal. So you run SLS DevTools, the name of your stack, and then you get an overview of all your Lambda functions, a graph of invocations and errors, the average duration of those functions, a cool 1960s like hacker movie map of where your servers are deployed, logs at the bottom of what's happening, and some new graphs that will be coming soon. That's released, and I welcome any feedback. If anyone's interested about it, feel free to ask me at the end. And yeah, I've been Ben. Feel free to follow me on Twitter. One of those takes you to the newsletter. One of them takes you to the blog article. I can't remember which is which, so subscribe to both. And if you have any questions, feel free. I think you need the microphone. Yeah.
So like, in terms of like performance, like, can you like talk a little bit about like the benefits like for that, like with using serverless over just like having a bunch of servers or a server? Like, is there any specific advantage in that kind of realm, you know, performance?
Sure. Yeah. So I don't have any metrics to pull off the top of my head, but for us on this project, serverless was really coming from a total cost of ownership. They didn't have the facilities to be managing these services. They've had a 10-year legacy. They've migrated from on-premise to cloud, and they were tired of dealing with servers. From a performance point of view, we've not had any problems. In terms of the application, it runs exactly at the time we're expecting. And we've not done a lot of measuring around it. With serverless, you do have the problem of cold start times. So that's the first time you invoke a Lambda function. It's not sort of in the it's not the right word, but like containerization cache of AWS. So if you do a warm invocation, so someone calls Lambda function, then someone else calls it 2 seconds later, they'll get a really fast response. The early one can be a bit slower. We can mitigate that by keeping our deployment package small, so keeping our Lambda small, keeping the number of packages small, and we've done a lot of that. So we've not noticed problems, but I don't have exact stats to pull off. There are quite a few articles dedicated to it, and I think there was one in the last newsletter, so feel free to have a look.
So actually, I have a question just on that. So did you package and deploy NumPy SciPy stack into Lambda ever?
I haven't, but Lambda layers would let you do it. So I've deployed PHP on Lambda. So to do that, you have to build a Lambda layer. So with AWS, there's a custom runtime API, which lets you package any runtime you want. If you deploy a Lambda layer, which is a way of sharing code between Lambda functions, you can then write what's called a bootstrap file. That ties AWS's infrastructure to your binary. If you compile that binary on an EC2 of the same AMI, operating system of Lambda, which you can find in their docs, it will run perfectly. So you could compile Python with all of its dependencies. The one thing you'd have to check out is will you go past the limit of your Lambda function in terms of code, but I think you'd get away with it.
Actually, I have a second question. I really love that terminal dashboard. What's that? What's the package for that?
Yeah, it's SLS DevTools.
So did you write did you use a framework for that or?
Yeah, it's using Blest and Blest Contrib, which are in JavaScript. And it's not a huge amount of code. We're building up features, and we're now on 60 stars, so it's super exciting.
All right, fine, JavaScript, okay. All right, anybody else?
Does the DevTools replace AWS console, or you could use it as a replacement to check CloudWatch logs for your Lambda functions, for your errors, if Lambda works properly and stuff like that?
Sure, no, definitely not. It's not a production observability tool. There are tools like Thundra, Lumigo, Epsagon, which are like dedicated logging providers for serverless applications. The CloudWatch dashboard isn't great at serverless yet. It has all the data, but not in a very user-friendly way. This is really like the Chrome dev tools of serverless. It's for developers to use when they're coding. It's not for getting alerts and observability in production.
Okay, thanks.
Anyone else? No? Well, thank you, Ben.
Awesome, thanks.